The unified atomic mass unit or Dalton is the standard unit that is used for indicating mass on an atomic or molecular scale. One unified atomic mass unit is approximately the mass of one nucleon and is equivalent to 1 gram per mole. It is defined as 1/12 of the mass of an unbound neutral atom of carbon-12 in its nuclear and electronic ground state, and has a value of 1.660538921, 73, A, 10^27 kg. The CIPM has categorized it as a non-SI unit accepted for use with the SI, and whose value in SI units must be obtained experimentally. The M without the unified prefix is technically an obsolete unit based on oxygen, which was replaced in 1961. However, some sources still use the M but now define it in the same way as U. In this sense, most uses of atomic mass units or M today actually refer to unified atomic mass units or U. For standardization, a specific atomic nucleus had to be chosen because average mass of a nucleon depends on the count of the nucleons in the atomic nucleus due to mass defect. This is also why the mass of a proton by itself is more than 1 AU. Atomic mass unit does not stand for the unit of mass in the atomic units system, which is rather ME. History: the relative atomic mass scale has traditionally been a relative scale, that is without an explicit unit, with the first relative atomic mass basis suggested by John Dalton in 1803 as 1 hour. Despite the initial mass of 1 hour being used as the natural unit for relative atomic mass, it was suggested by Wilhelm Ostwald that relative atomic mass would be best expressed in terms of units of 1/16 mass of oxygen. This evaluation was made prior to the discovery of the existence of elemental isotopes, which occurred in 1912. The discovery of isotopic oxygen in 1929 led to a divergence in relative atomic mass representation, with isotopically weighted oxygen given a value of exactly 16 atomic mass units in chemistry, while pure 16O was given the mass value of exactly 16 in physics. The divergence of these values could result in errors in computations, and was unwieldy. The chemistry AM, based on the relative atomic mass of natural oxygen, was about 1.000282 more massive than the physics IAM, based on pure isotopic 16O. For these and other reasons, the reference standard for both physics and chemistry was changed to carbon-12 in 1961. The choice of carbon-12 was made to minimize further divergence with prior literature. The new and current unit was referred to as the Unified Atomic Mass Unit U and given a new symbol U, which replaced the now deprecated M that had been connected to the old oxygen-based system. However, modern sources often still use M in place of U, and define them in terms of carbon-12. In general, AM probably does not refer to the old oxygen standard AM, unless the material is older than the 1960s. The Unified Atomic Mass Unit U was defined as terminology. The Unified Atomic Mass Unit and the Dalton are different names for the same unit of measure. As with other unit names such as Watt and Newton, Dalton is not capitalized in English, but its symbol DA is capitalized. With the introduction of the name Dalton, there has been a gradual change towards using that name in preference to the name Unified Atomic Mass Unit. In 1993, the International Union of Pure and Applied Chemistry approved the use of a Dalton with the qualification that the CIPM had not given its approval. In 2003, the Consultative Committee for Units, part of the CIPM, recommended a preference for the usage of the Dalton over the Unified Atomic Mass Unit as it is shorter and works better with prefixes. In 2005, the International Union of Pure and Applied Physics endorsed the use of the Dalton as an alternative to the Unified Atomic Mass Unit. In 2006, in the 8th edition of the formal definition of SI, the CIPM catalogued the Dalton alongside the Unified Atomic Mass Unit as a non-SI units whose values in SI units must be obtained experimentally, units accepted for use with the SI. The definition also noted that the Dalton is often combined with SI prefixes. In 2009, when the International Organization for Standardization published updated versions of ISO 80000, it gave mixed messages as to whether or not the Unified Atomic Mass Unit had been deprecated. ISO 80000-1 2009 identified the Dalton as having earlier, been called the Unified Atomic Mass Unit U, but ISO 80010-2009 catalogued both as being alternatives for each other. The 2010 version of the Oxford University Press Style Guide for Authors in Life Sciences gave the following guidance: use the System E International DONITA copyright S wherever possible. The Dalton, or more conveniently the KDAR, is a permitted non-SI unit for molecular mass or mass of a particular band in a separating gel. At the same time, the author guidelines for the journal Rapid Communications in Mass Spectrometry stated the Dalton is a unit of mass normally used for the molecular weight. Use of the DAR in place of the U has become commonplace in the mass spectrometry literature. The atomic mass unit, abbreviated AM, is an archaic unit. In 2012, in response to the proposed redefinition of the kilogram, it was proposed that the Dalton be redefined as being 0.001/nor kg, thereby breaking the link with 12C. This would result in the Dalton and the atomic mass unit having slightly different definitions, but the suggestion is that the older unit should be superseded by the new Dalton. Relationship to SI, the definition of the mole, an SI base unit, was accepted by the CIPM in 1971 as, the mole is the amount of substance of a system which contains as many elementary entities as there are atoms in 0.012 a kilogram of carbon-12. Its symbol is mol. When the mole is used, the elementary entities must be specified and may be atoms, molecules, ions, electrons, other particles, or specified groups of such particles. The definition of the mole also determines the value of the universal constant that relates the number of entities to amount of substance for any sample. This constant is called the Avogadro constant, symbol Na or L, and is equal to 6.02214129, 27, A, 1023 entities per mole. Given that the unified atomic mass unit is 1/12 the mass of one atom of carbon-12, meaning the mass of such an atom is 12 Au, it follows that there are Na atoms of carbon-12 and 0.012 kg of carbon-12. This can be expressed mathematically as Na equals 0.012 a kilogram per mole, or Nau equals 0.001 a kilogram per mole. Masses of proteins are often expressed in Daltons. For example, a protein with a molecular weight of 64,000 grams molar 1 has a mass of 64,000 Daltons, or 64 kDa in short. Examples: a hydrogen 1 atom has a mass of 1.007825 U. By definition, a carbon-12 atom has a mass of 12 U. A molecule of acetyl salicylic acid has a mass of 180.16 U. Titin, the largest known protein, has an atomic mass of 3-3.7 megadaltons. See also, Kendrick mass, mass-to-charge ratio, atomic mass constant, notes and references. External links, atomic mass unit at sizes.com.